Hi ladies, in this video we're going to go through the challenging questions for 8F, which is using tree diagrams. I look at this picture and I think of Ronald McDonald for some reason, like the yellow and the red and white. Anyway, so question 9, 2 socks are selected at random from a drawer containing 4 red and 4 yellow socks. Find the probability that the 2 socks will be of the same color if the socks are drawn without replacement. Find the probability that the 2 socks will not be of the same color if the socks are drawn without replacement. So we've got 2 socks are selected at random from a drawer containing 4 red and 4 yellow socks. Okay, so let's draw our tree diagram. So we can have a red sock or a yellow sock, and then a red sock or a yellow sock. And we're doing without replacement, so remember they do go down in numbers. And there's the same number, so we're going to have, we've got 4 red out of 8 socks and 4 yellow out of 8 socks. So remember, I did this in a previous video, but just in case you didn't watch that video, I'm going to do here. So we've got 4 red socks. Do they look like socks? I'm thinking, why is she drawing red J's? And then 4 yellow socks. Now, if I pick a red sock, first of all, that goes. I'm left with 7 socks. Actually, I'm not going to put my probability there, so I should put it up the top. So 3 red socks out of 7 in total, and choosing a yellow sock, so the probability of the yellow sock, there's still 4 out of 7. Okay, so this number here, okay, comes from how many is the probability of selecting a red, and this one here. And let me draw. It's interesting. Oh, well, there it goes. It's a bit delayed. It's the probability of getting a yellow sock, and now that just looks weird. So let's just take that off. All right. Then we can say, well, let's put that red sock back. Okay, and this time we've selected a yellow sock. So I've taken a yellow sock. So the probability of getting a red, there's still 4 left. And there's 7 socks now. And the yellow, that one was taken, so now we've got 3 yellow and 7. So just your outcomes, you read along your branches. And yellow, yellow. So the 2 questions, I'm just going to get rid of those socks now. That was quick. Find the probability that the 2 socks will be of the same color. So you can have either red, red, or yellow, yellow. So we just go along the branches. So 4 over 8 times 3 over 7. And that is 12 over 56. And here we've got 4 over 8 times 3 over 7. So it's the same thing, 12 over 56. So in total, we've got, so the probability of them being the same is 12 over 56 plus 12 over 56, 24 over 56, and then just simplify that. So is that going to be, oh gosh, 12. I always find it easier if they're even numbers just to keep halving them. So 12 over 28. So 6 over 14, 3 over 7. Okay, I'm just making sure that that is correct. Looks pretty good. Find the probability that the 2 socks will not be of the same color if the socks are drawn without replacement. So basically, we're going to be adding these up. So 4 over 8 times 4 over 7, which is 16 over 56. And then we've got the same, I feel like I've said the wrong number before. 16 over 52, 16 over 52 gives you 32 over 52. So the probability that they're different is 32 over 52. Okay, so that's going to be 8 over, oh gosh, 13. I did the wrong number, didn't I? I think I said 56 before and then I wrote 2. Why did I write 2 there? Sorry, girls. Let's just start that again. Sometimes my mind is thinking ahead and I think of numbers and they're different to what I write. So let's just get the numbers correct. All right, and I'm going to rub out that 8. So now we should have, okay, so 4 over 7. And when you think about it, this number here is the same as 1 minus the probability that they were the same. So we already worked that out. So 1 minus 3 on 7 gives you 4 on 7. So you could have done it that way as well. All right, question 11. Containers A, B, and C hold 4 marbles each, all of which are the same size. The following table illustrates the marble colors in each container. A container is chosen at random and then a marble is selected from the container. Draw a tree diagram to help determine all the possible outcomes and the associated probabilities. Suggestion: you will need 3 branches to start, representing the 3 different containers that can be chosen, followed by 2 branches for each of A, B, and C. Yep, cool. So first of all, we got to select our container and then the marble. So our container is going to be a big one. So always make sure you give yourself enough space. So we can have container A, B, or C. So container. And then we've got our marble. So we can have purple or green. Purple or green. Purple or green. Okay, so getting the container, there's 3, so the probability is the same. So it's 1/3 for each. Remember, the probabilities along your branches or going down for the step all add up to 1. Okay, so for container A, we have 1 purple and 3 green. So that's going to be 1 over 4, 3 over 4. Hold on, I feel like I got the wrong number. No. So there's 4 containers, 1 purple and 3 green, 2, 2. So 2 over 4 and 2 over 4. Notice how they add up to 1. And then 3 and 1. Okay, so we've drawn our tree diagram, a triagram. I just made a word up. And all the possible outcomes and the probabilities. Okay, so I'm going to do that. So remember, you read along your branches. So we've got container A, purple. You can have container A, green. Container B, purple. Container B, green. Container C, purple. Container C, green. And then your probabilities, you just multiply along your branches. So 1/3 times 1/4 equals 1/12. 1/3 times 3/4 is 3 over 12. And then 1/3, oh gosh, go away. 1/3 times 2/4 is 2/12. And this one's the same. Oh my gosh. Sorry, girls. Probability really takes it out of me. It's so many numbers, so many things to remember. Maybe it's explaining it at the same time. I'm finding challenging. Okay, so 3 over 12. I'll know at the end if I've made an error somewhere, so it's all good. Hopefully I'll realise. Okay, so how did I just write 13? That's just so random. Okay, let's just put the 2 there. Okay, so we add up all them, so we should get 12 over 12. So remember, all our outcomes should add up to 1 or 12 over 12. So we've got 1, 4, 6, 8, 11, 12. Yay. Okay. Total possible number of outcomes. Total number of outcomes. Okay, just 1, 2, 3, 4, 5, 6. Okay, so 6 different possible outcomes. Find the probability of A and purple, so it's 1/12. B, green, is 2 over 12, which we can simplify to 1/6. C, purple, is 3/12, which we can simplify to 1/4. Find the probability of obtaining a green marble. So we want to just do this down here, the probability that it's green. It doesn't matter where it comes from, it just has to be green. So we just add up everything that is green. So just so we know, I'm going to underline it in green. Oh, scroll for me, please. There we go. So we add all of them up. Now, when you're adding fractions, you always need to have the same denominator. So I'm going to keep them all over 12. So we've got 1/12 plus 2/12 plus the last one is 3/12. So in total, I've got 1, 3, 6/12, which is a half. Okay, so the probability of getting a green is half. Trying to make sense because there's the same number of green as there is purple. Okay, I think that's the last question. Bye, girls.